No guarantee that you're going to remember everything from today and be able to walk away and do it, okay? So today is, you don't have a really, really good intrinsic sense of what's going on for today's lesson, okay? Some of it's going to be easy, some of it's going to be a little bit tricky. I'll do my best, but there's a very good chance that many of you will have to ask questions about what we do today, okay? If you all just went off on your own and were able to figure it all on your own, that would be a very abnormal class, okay? So sometimes when you have questions on your homework, why do I have questions? I can usually figure out math. There should come a time where we're pressed hard enough to where you have to ask the questions, right? And so some of those may come up during this unit. All right, let's talk about logarithms. What are logarithms? Logarithms are related to exponentials. In particular, log base a of x means a base of a to what power is equal to x. That's what it means by definition. Logarithms are useful for us because they help us find what we call exponents. So we're just going to start expressing these in exponential form. We have a base on the bottom. We have an exponent on the side. So this means 2 to the 5th power is equal to 32. These two things are absolutely synonymous. They mean the same thing. Everybody okay with that? Okay, what's the next one?
6 squared equals 36.
Good. And after you write it, you should be able to say, oh yeah, 6 squared is 36. The next one? 12 to the 0 is equal to 1. Very good. The next one we have 3 to the 5th power is 243. What's different about E and F is those, you don't see a base and it's written as ln. ln is a logarithm with a base of E. So this reads logarithm base E of E is equal to 1. We don't write log base E ever. We always write ln. That stands for natural logarithm. In French, it was logarithm naturel. They put the adjective afterwards instead of in front. Therefore, you get ln. Okay?
Thanks, French.
Yeah, okay. He already knew that. He's like, amen to that one. All right. So this means E to the 1st power is equal to E. That's what that means. So I'm not going to write log base E all the time, but when you see natural log, you say, oh yeah, the base is E. What's the exponent? 0 equals 1. Does that make sense that E to the 1 is, or E to the 0 is 1? Good. So let's move on. Now we want to take these, our exponential representations, we want to express them as logarithmic equations. So we have the log base 2 of 16 is equal to 4. Again, the base goes here, and the exponent goes there. Okay? Log base 2 of 16 is equal to 4. The next one, I would write log base 10 of 100,000 is equal to 5. Now, if you look at your calculator, I'll pull that up after people write that down, but if you look at your calculator, it has 2 logarithm buttons on your calculator, as log and as ln. But notice it doesn't ask you for a base. The base of the logarithm is assumed to be 10. So if you ever see this expression, log base 10, you could just write log of 100,000 is equal to 5. If it doesn't have a base written, it's assumed that the base is 10. Everybody got that? Okay, please do letters C, D, E, and F on your own. Go. Any questions on any of those?
You're right.
Grade your test. Questions going once, twice, 3 times flip, okay? All right, so we'd like to be able to evaluate some of these logarithmic expressions. Some of them are easy, some of them are pretty challenging, okay? This is log base 4 of 64. So that means 4 to what power is equal to 64? That's what this means. So what would the log base 4 of 64 be? It is 3, because it's 4 to the 3rd power. The next one is 3 to what power is equal to 1/9? Negative 2. So notice 3 squared is 9. So if you have the negative power, it's going to flip it. So it is negative 2. This means 8 to what power is 8? And you get 1. Any questions how I produce those? Look at the next 6 problems. Do you agree that those look a little bit more challenging?
Yeah.
So I need to teach you something that you do not yet know. This is hard for me to do, to convey knowledge to you. I'm going to do my best. You are going to flip back 1 page. We want to be able to write what these couple things are here. And as we do, I'm going to, well, I want the people viewing this video to be able to follow on as well. So I'm going to try to get some space here as I write, and then I'll come back up, okay? So, all right, here we go. 5x is equal to 300. Yesterday we solved that. We divided by 5, right? You don't have to write this down. This is all stuff that we did yesterday, you know. X is equal to 60, right? You say, well, yeah, the multiplication, division, those are what we call inverse operations. They undo each other, right? And if you had, say, 5 plus x is equal to 300, you would subtract 5 from both sides and say x equal to 295. You've learned that addition and subtraction, they undo each other. They are what we call inverse operations, so they cancel out. And that's pretty intuitive to you. And I can even explain that to my youngest, Tenley, and she would be like, okay, I can make sense of that. It kind of works within my brain. But what if you were given this? X to the 5th is equal to 300. How do we get rid of a 5th power?
You square root. So
Not square root, but the 5th root. Now, you've learned that that works, but do you understand if we were trying to explain that to Tenley? She's like, well, why do those just go away? Like, you tend to think of things in terms of addition, subtraction, multiplication, division. It's like, why do those just cancel? But you guys have begun to trust that, right? So here's the big idea that you're going to be dealing with in this unit is this right here. Yesterday I also showed you this. 5 to the x is equal to 300. And the question was, what can we do to make the 5 go away? And yesterday what we did is we did this guess and check process, didn't we? Came away 3.545. Well, the way you get the 5 to go away is this. You take the log base 5 of both sides. And what happens is this disappears and you get x. Log base 5 and 5 are inverse operations. They undo each other. So when you see this right here, log base a of a to the x, those disappear, leaving you with x. Those are inverse operations. And if you get a to the log base a of x, those are inverse operations as well, leaving you with just x. Now, right now, that might look a little bit crazy. I'm going to try to help you see that in your brain. I'm going to go back to this example here. It says log base 4 of 64. Would you guys agree that that's the same thing as log base 4 of, I could write 64 as 4 to the 3rd power, right? Look, those disappear, giving you just 3. You see that? Here you have log base 3 of 3 to the negative 2. 1/9 is 3 to the negative 2, isn't it? They disappear, give you negative 2. Here you have log base 8 of 8 to the 1. Those disappear, giving you 1. They are inverse operations. They undo each other. So now we can tackle on these problems. Log base 5 of 5 to the x plus y. What's going to happen?
5's disappear, log 5 and 5.
And I get x plus y. 3 to the log base 3 of 7. 7.
What is that first 3? Like,
It's a base. 3 raised to the log base 3 of 7.
Alright.
See that?
Yeah, I think so, yeah.
This one, natural log of e to the negative 2. Everybody agree that 1 over e squared is the same as e to the negative 2? Well, these are the same base, aren't they? The base of natural log is e, and I have a base of e, so these disappear. Natural log and e undo each other. I get negative 2 out of that. Sometimes the problems aren't quite that intuitive. They're a little bit more challenging. Like this one, log base 4 of 8. We would like to find out that exact value. That means 4 to what power is equal to 8? What do you think?
3 halves.
3 halves. Why?
I was doing my homework there.
You're just kind of guessing and coming up with one?
Yeah.
Let's talk about why it works. Okay, 4 to the 1 is 4. 4 to the 2 is 16. You know it's got to be somewhere between there, right? But notice that 4 and 8, they're not that relatable, except there is a base that multiplies to both 4 and 8. What's the base that multiplies both 4 and 8? 2. Watch how I can rewrite this. 2 squared to the x power, that's like my question mark there, that x. So 4 is the same thing as 2 squared, and then 8 is the same thing as 2 to the third. So in other words, a power to power, I have 2 to the 2x is equal to 2 to the third. Once the bases are the same, we can then make the exponents the same. 2x equals 3. What would x be? 3 halves or 1.5. Look at the next one. What is the base of this logarithm? 10. Would it be nice to be able to write 0.00001 as a power of 10? What is 0.00001 as a power of 10? 10 to what power?
5.
Negative 5. And we have the square root of that. Square root is what power? When you take square root, what power is a square root?
1 over 2.
1/2. So sorry about that. I can rewrite this expression to be 10 to the negative 5th to the 1/2 power. So we get the log of 10 to the negative 5 halves. What happens with log and 10? They reduce because the base of a logarithm is 10, and we get negative 5 halves. Try letter I on your own. Don't be intimidated by it. Try something. Try something. Try anything. See if you can figure that out without the use of a calculator at all. Give you 25 more seconds to kind of think through something. Okay, 2 to what power is 4 to the 1/3? And so I'm going to rewrite 4 so that it has a base of 2. That's 2 squared to the 1/3 power. Notice how I have a power to power I can multiply. That means 2 to the x is equal to 2 to the 2/3. Obviously, in this situation, x is 2/3. A little tricky? Thumbs up if you got that on your own. Good job. Okay. We went through examples 5 and 6 of the previous classes. We're not going to do that today. We'll pick up a little bit of it on Monday, but we will finish off example 4 here. We should be able to take logarithmic expressions, be able to find what x is. This is log base 2 of x is equal to 3. That means 2 to the third power is equal to x. So if that's the case, what would x be? What I'd like you to do is rewrite these expressions. Try letters B, C, D, E, and F on your own. Some of them will be tougher, some will be easier. See if you can solve for x within those given expressions. We get questions on B, C, or F. Then I'd like to do D and E with you. Log base x of 49 is 1/2. A lot of times people write this x to the 1/2 is 49, and they associate these two things. They associate square root and 49 together, and they automatically think of x being 7. But this is saying what number do you take the square root of to get 49? So you would literally want to square both sides in order to figure that out. Ends up being x is 2,401, not 7. And for the next one, this means 2 to what power is equal to 0? What power do you take 2 to get 0?
You can't.
2 to the 1 power is 2. 2 to the 0 power is 1. You say you can't. Why not?
I mean, unless you get like a negative number that's like so big that it's just like infinitely close to 0.
Okay, Ben's got a really good idea. He's summarizing that in the best way he can. I'm going to draw kind of his idea. What Ben is saying is that if you put in negative numbers, we learned this in the graph yesterday, doesn't this graph look like that? So Ben is saying it doesn't matter what number you plug in for x, you're still going to get a number that sits just above the x-axis. Does this graph ever cross the x-axis? No. So 2 to the x, it can never equal 0. It can never produce something negative. That is not possible. This is undefined. Is that what's happening inside your brain?
Yeah.
Which you raise an excellent question. Is there a large enough negative number to produce 0?
It's still not 0.
What about negative infinity?
Oh, I suppose. Maybe.
But infinity is not a number. It's an idea. We can't point to it on the number line. And the ability to deal with infinity and ask those questions, that's what calculus is. The word calculus comes from calculate, the ability to calculate the infinitely large and the infinitely small. And then our brains explode. There's stuff everywhere. Okay, we'll pause there. Great job. We'll pick up with the graphs on Monday. So as you look at your homework, I wouldn't worry too much about the graphs. I will do my best to get these scanned in and up online for answer keys. And yeah, enjoy your turkey day.